Hi all. Today instead of lead coding, we'll do a Linux kernel module. For a change, and we'll try to demonstrate some of the important APIs from Linux kernel. So let's look at two different APIs. One is the PCI related, another is the Workqueue related. So as you can know, as do you know, if you know that, probably know already that when you work at the lower level, at the hardware level, you have to sometime you have to work with the PCI devices. Sometimes a hardware engineer might come to you and say, I need a gap between accessing these two registers in different subsystem within their hardware, or what they call as IP blocks. Now, so how are we going to basically achieve that? So we'll take a look. So our kernel module. So before I show you what is going on. So here is the workqueuebetter.c. I have a file known as workqueuebetter.c. In this workqueuebetter.c, we would see how it is structured. So this is a very simple kernel module, which in case you have ever played with Linux kernel modules, you would know that there's nothing great about that. You got a init function and exit function. And in the init function, you are you're basically scheduling a delayed work functionality, and it's kind of a callback. That kernel basically does it for you by having its own kernel threads running. As you know already, kernel has the capability to run threads inside it. So basically, it can do a callback for you. It can be running a callback for you. So you do it. So this is a very simple init function. In fact, this is just like a module loaded. You initialize the work and then you schedule the work. If you see in simple terms, and rest is just details. So how do you? So basically, you got to have a header known as Linux workqueue.h, in which you got to have this. You got to understand the delayed work kernel data structure, and so you have a variable PCI scan work, which is of type struct delayed work, and then you have a function which is your kind of a callback function or the thread function, which gets invoked by the kernel, which will get invoked when we do schedule delay. So see in the init function, you scheduled it and to run every 60 seconds, which is 1 minute, because HZ is actually number of GPs every second. So 60 second is like 1 minute. That's how you do something 60 times HZ. If I didn't do 60, it will just be every second. So and then the reason it gets periodically scheduled is it runs periodically is because I kind of schedule itself again within itself. So as you can see, schedule delayed work is being called here. So that's your work functional. Simple. Have a PC, have a struct delayed variable call init delayed work from that, with passing the address of that structure, that variable structure, and then have your thread function or the callback that will be called by kernel, and then you have scheduled delayed work. That's it. So there are also other variants of it, by the way. If you want to do scheduled visual delayed work on a particular CPU, that is also possible. But we'll not go into that. We just want to keep it simple. So now, what the PCI related thing your callback function does is also very simple. What it does is it does PCI get device. So PCI get device is a function that, let's take a look at its prototype in Linux kernel. So what is its prototype? So as you can see, it's vendor device, and the third parameter is from. This is the same as what it returns, and that third parameter has its some significance. So the way you do is, as you can see, that if you give your from, there is a third parameter as PCI deb. Basically, the struct PCI deb, and if it is not null, you pass it. If it is a null, it will start a new search is initiated. But if it is not null and you pass it what it returned to you, it will start from what you passed it on. That way, this is a cool trick to basically iterate over all PCI devices in your system. So you see the PDAB is passed So while it's not equal to null, PCI get divide doesn't return equal to null. You basically keep going, and that way you can schedule all the PCI devices. So that's it. So now let's try to build it. So as you do now, you also show make file. What does the make file looks like? Make file is very simple. Just have your module C file equivalent to .o under OBJM category, and that's it. That's all you need to have. So now, if you do sudo make, sudo make, what happens? There you go. Shows it has been built. When you do a insmod, I think I probably did an insmod before. So you see, this is how you can do insmod. You see, you can insert your module. So what make does is it creates a .ko, that is a kernel object file. That is basically a module's object file that that is created and you insert it. So I think I've already done the insert. I was going to say file already exists, but basically that's how you insert it. Now you see what it is it really working. How do you know it is working? So you do sudo dmessage. So let's do sudo dmessage. There you go. So as you can see, it is performing periodic scan every 1 minute. So if you again see what you see performing periodic scan is coming from here. Performing periodic scan. So there you know, there you go. You know how to write a simple Linux kernel module which will do a couple of simple things like scanning, going, iterating over all PCI devices, and also running a task periodically or a thread periodically. Kind of simple functionality. So with that, I'll leave you guys alone. This is a very simple. It's keep it simple, small, and tight. So that is the goal of Linux kernel anyway. So Linux kernel hacking is something that is to get you creative going and change from lead coding because you got to also build your concepts. It's not enough to just do no algorithms. So with that, I'll leave you alone and see you next time and do something better. Maybe I'll explain to you the ideas behind the idea behind the process context or interrupt context. So apparently this thing PCI scan work function runs in process context. So process context doesn't mean user space processor. It's still kernel only, but there are certain things you could do inside which if it were a different if you had scheduled work through different ways like tasklets and all which run more like in an atomic context you may not be able to do, but I'll not confuse you further. I'll basically keep that for the next video. So see you next time. Bye bye.